Hello and welcome to part 2 of this video about how optical storage devices work. In this part we're going to look at how to write to disks. Now there are 3 different types of disk, and the first one we're going to look at is writing to read-only disks. So these are the sort of disks that you get when you buy a CD with music on it, or a DVD with a movie, or a Blu-ray disc with a game on it. So let's have a look how that works. So the first thing we do is we start with some high quality optical grade glass, and we polish that glass all the way down to 10 nanometers so that it's super smooth. Once we've polished it, we then clean it using detergents, deionized water and ultrasonic bath, and then we remove all dust, all oils, all imperfections. Now it is ready, once it's been cleaned, for a photoresist coating. Now this coating is similar to the sort of coating that you get in microchip manufacturing, and we just pour it on, and what this does is it gives us a full layer over the disk that is then sensitive to laser light, which we're going to use in the next step of the process. And once it's done, we then dry it and we bake it off so it's ready for the laser light. Okay, which is the next step of the process. So here what happens is there's a laser beam that writes data all onto the disk. The disk is spinning around, and as it's going along, the laser is turning on or off, and that laser is hitting the photoresist. You can't see it because it doesn't make any visible mark, but what it's doing is it's leaving tiny microscopic exposed areas where it's hit the photoresist. So there are holes, tiny little holes in that photoresist coating that we've done, ready for the next process, next step in the process. So the next step in the process is development. And in this step of the process, what we do is we take that exposed glass and we put it in a bath in order to develop it. I think it's like an acidic bath, and all the layers that have been exposed due to the laser light where the photoresist has been burnt away, those bits then dissolve. The glass below there dissolves, and because it's only got the bits where the laser has hit the glass, then it ends up with microscopic pits and flats. So now we've got a glass disc, and that glass disc has tiny little depressions in there where it's been hit by the laser, and it's ready for the next step of the process. Okay, and we can see that there. And the next step of the process we move on to is metallization, which is the nickel coating of it. So what we do here is we apply a very thin conductive layer of nickel using vacuum spluttering or electroless plating, and all this does is it gives us a very thin layer of conductive layer ready for the next step. And we need that conductive layer because we're going to use electroforming, and it's going to work as the cathode. Okay, so now we've got a very thin layer of nickel on there. What we now need to do is we need to increase that thickness of the nickel so that we can actually peel off a whole metal impression that's going to be used later on. So we're going to peel off a whole metal disc. And the way that works is you plug in the nickel side into the cathode. That becomes the cathode. And through electrolysis and electroplating, what happens is a thicker layer of nickel is built up on top of building upon that existing layer. And it keeps on building up until about a 0.3 millimeter thickness layer is formed. Once it's about 0.3 millimeters thick and we've got more and more nickel on there, it's then ready to be peeled away from the glass master, and the glass master is then either discarded or used again later on. Okay, it's this tiny 0.3 millimeter thick nickel metal plate that then gets passed to the next step in the process, which is injection molding. Okay, so what happens in injection molding? Well, basically the nickel stamper is mounted inside of an injection molding press, and then molten Optical grade polycarbonate, which is plastic, is poured into the mold, and then it's molded under high pressure and temperature so that what comes out the other end is the CD that is finished. And because it's an exact opposite of what's been done in the press, it should then have the pits and flats as required. Okay, so when that plastic cools and solidifies, all the data is there and your CD is ready to move on to the next step, usually where they're applying labels and stuff. Okay, so that's how data is written to a singly writable disk. But what about data that's written to recordable disks? So recordable disks, these are what we call CD-R, and these are disks that can be recorded to, but only recorded once. So it's a single write recording. So how does that work? Well, let's have a look. So let's have a look at the different layers on these disks. These are a bit different. So these disks have a polycarbonate substrate, and that's the protective layer that the laser passes through first. And it's on the underside of the disk. So if you look at this diagram here, now it's as if your disk has been placed upside down and you can see the shiny side. Okay, and this first layer is just a protective layer, and the laser passes straight through. The next layer is the die recording layer. So this is the layer that's going to contain the actual ones and zeros. And basically, when a laser hits it, it darkens the die to form a pit or a land, depending whether the laser has hit it or not. And then below there is the reflective layer, so that if it's not gone hit that dark pit, then it will actually bounce back from the reflective layer, going back through so that it can be read later on, as we saw in the previous video. So let's have a look at that process in a little bit more detail. Let's see that in action of writing the die. Okay, so the laser functions at a higher power than is normally used during reading, much higher. And when it does fire the laser, usually it heats that die in that area of the disk to a much higher temperature, between about 250 and 300 degrees Celsius. And as it does that, as you can see here, what happens is, because where it's hit, it causes a permanent darkening or a slight molecular change in the die. And because it's darker, those darker spots absorb more light, which effectively, when the CD is reading it, that has the same effect as a pit on the pressed disk. Okay, so that's how singly writable DVDs or CDs work. Now let's have a look at the next step in the next type of disk, and this is the final type, which is rewritable disks. So these are CD-RW or RE, depending what you're buying, and these work in a similar sort of way, but slightly different. So these ones, instead of having a die layer, they have a phase change alloy layer. So again, your laser light passes through a polycarbonate underneath, just going through, and then it hits the phase change alloy layer. And these ones here have tiny little spots of phase change alloy that can alternate between crystalline states, which is the reflective state, or a amorphous state, which is the non-reflective state. Okay, and obviously then below there, as previously, you've got the reflective metal layer, which would then bounce back up. Okay, so let's have a look at that in action. So the writing process, this one's a little bit different. So you can see here, what I've got here is a CD that's already had something written to, and now the laser is going through the process of rewriting it. And you can see here that there are two different types of pulse that are sent. The first one is, you'll see the bright yellow one, is a high power but short duration pulse. And the idea of this one is it melts that phase change material, the alloy, and cools it rapidly. And this creates because it melts quickly and cools rapidly, it creates a non-reflective surface, which we would indicate as a binary 0 when it is read. Or the other way we can do it, as you can see here with the slightly dimmer laser light, is a medium power longer pulse. Now this is still a higher power than you would use to read, but it's less than the power of the short pulse. And because it's got less of a power, but we do it for longer, What this does is it holds the temperature just below melting point for quite a while. And this gives the alloy, the material underneath, the phase change layer, chance to crystallize. And because it crystallizes, it becomes reflective. And therefore, it becomes a binary 1. So there you go. And because it's just all you're doing is changing the phase of it from crystallized to and amorphous, then you can do that as many times as you like, which makes it rewritable. There you go. So those are the 3 different types of disk that are writable. And that concludes the video. If you like the video, then feel free to like and subscribe. And if you've got any requests for future videos for computer science, then please let me know. Thank you very much.